So in this lesson, we're going to take compounding interest even a step further. What we have learned was you can compound interest on an annual basis, on a semi-annual basis, a quarterly basis, even a daily basis. But there is also such a thing as continuous compounding, meaning that it is being compounded continuously, not just every day, every hour, every second. There is a formula for continuous compounding, and you may or may not have used it before, but it involves the E button. And E is an irrational number like pi, but we use E a lot whenever we're talking about continuous compounding. If you're looking for it on the calculator, see the LN key here, it's right above it, which means to get to it, you have to hit the second button first and then get the e to the x power. So we're going to be raising e to a power in this formula to figure out how much an account would be worth if the interest was being compounded continuously. So let's look at the formula first. The formula for continuous compound interest is this right here. B equals P times e to the RT power. We call it the PERT formula, P-E-R-T. B is the ending balance, P is the principal, same principal amount, what we start with. E is that exponential base that I showed you on the calculator, and then the E, just the E, is going to be raised to this power of R times T, where R is the rate, we're used to that, and T is the number of years. Okay. So if you deposit $1,000 at 4.3% interest compounded continuously, what would your ending balance be after 5 years? So T is 5, R is 0.043, and this is your principal amount here. So plugging them in to the calculator, or I'm sorry, to the formula, $1,000 in principal times E to the 0.043 times 5, the rate times the time. That's all I'm doing is plugging them into the formula. So to get this answer, if you're on a higher quality calculator, I guess you can probably punch them all in, but if you're on one of these, you have to do PEMDAS, so we have to get the exponent. We have to figure out what this exponent's equal to first. So 0.043 times 5. So this is the process and the steps in order. 0.043 times 5 gives you 0.215. Now I'm going to raise e to that power. So without taking it out of my calculator, I'm going to hit second and then that e to the x. So second e to the x gives me this number, 1.239861897. So I've raised e to that power. Now all I have to do is multiply it times 1,000. And that gives me 1239.86, which is what they come up with as well, 1239.86. So let's try this one here. Craig deposits $5,000, so my principal amount is $5,000. At 5.12% interest, so my rate is 0.0512. Compounded continuously, which means I'm going to use E, for 4 years. So my T is 4. What would his ending balance be to the nearest cent? So the balance is equal to the principal amount times E to the RT power, R times T, so 0.0512 times 4. So I know these sound difficult, but you're really just plugging the numbers into the formula and letting the calculator do the work. It's really not that difficult. Multiply these exponents first, and then we'll take e to that power. So 0.0512 times 4 is 0.2048. Now I'm going to raise e to that power. So all I have to do is hit second and then e to the x button, and that will give me that number, which is 1.227279584. Multiply that times 5,000. That's the last step. 6,136 and 0.39. Oh, the 7's going to push the 9 up, so that's going to give us 40 cents. So $6,136 and 40 cents would be their balance after 4 years depositing that much at that interest rate, compounded continuously. Continuously compounding. That's it, assignment 22.